Hello everyone, Ganesh Chaudhary here. Today I am going to explain the topic of database normalization. This is the process which allows you to winnow out the redundant data from your database. This involves restructuring the tables to successfully meeting higher forms of normalization. A properly normalized database should have following characteristics: scalar values in each field, absence of redundancy, minimal use of null values, minimal loss of information. Levels of normalization. Levels of normalization based on the amount of redundancy in the database. Various levels of normalizations are first level normalization form, second normal form, third normal form, Boyce-Codd normal form, fourth normal form, and onwards. These are the pictorial representation of the normalization. First normal form. A table is considered to be in 1NF if all the fields contain only scalar values, as opposed to the list of values. As you can see in this example, there are multiple values for in each box. So this is not in first normal form. Uh, Now if you want to convert it into first normal form, we have to take the following steps. Place all items that appear in the repeating group in a new table. Designate a primary key for each new table produced. Duplicate in the new table the primary key of the table from which the repeating group was extracted or vice versa. Uh, Functional dependencies. If one set of attributes in a table determines another set of attributes in the table, then the second set of attributes is said to be functionally dependent on the first set of attributes. Like in this example, ISBN depends on title and ISBN depends on price. There are few more examples of this. Functional dependencies. Here also there are five more examples to see. Second normal form. For a table to be in second normal form, there are two requirements. The database should be in first normal form, and all non-key attributes in the table must be functionally dependent on the entire primary key. And here is the example where this is not in second normal form, as AU address does not belong to a key. An AU address functionally depends on AU ID, which is a subset of a key. And a few more examples of this. And if you want to convert some schema into second normal form, we have to take the following steps. If a data item is functionally dependent on only a part of the primary key, move that data item and that part of the primary key to a new table. If the other data items are functionally dependent on the same part of the key, place them in the new table also. Make the partial primary key copied from the original table the primary key of the new table. Place all items that appear in the repeating group in a new table. And here is the conversion for a simple example. The old schema is given and the new schema are also provided. A few more examples. Third normal form. This form dictates that all non-key attributes of a table must be functionally dependent on a candidate key. That is, there can be no interdependency among non-key attributes. For a table to be in third normal form, there are no two requirements. The table should be in second normal form. No attributes is transitively dependent on the primary key. Here is an example given, and this is not in third normal form, as both price and page count depend on a key, so it's in second normal form. Transitively, title and pub ID depends on price, hence not in third normal form. A few more examples. To convert some schema into third normal form, we have to take the following steps. Move all items involved in transitive dependencies to a new entity. Identify a primary key for the new entity. Place the primary key for the new entity as a foreign key on the original entity. And here is an example given. Boyce-Codd normal form. BCNF does not allow dependencies between attributes that belong to a candidate key. BCNF is a refinement of the third normal form. in which it drops the restriction of a non-key attribute from the third normal form. And here is an example given. To convert some schema into BCNF, we have to take the following steps. Place the two candidate keys in separate entities. Place each of the remaining data items in one of the resulting entities according to its dependency on the primary key. Decomposition, loss of information. If decomposition does not cause any loss of information, it is called a lossless decomposition. If the decomposition does not cause any dependencies to be lost, it is called dependency preserving decomposition. Any table schema can be decomposed in a lossless way into a collection of smaller schemas that are in BCNF form. However, the dependencies preservation is not guaranteed. Any table can be decomposed in a lossless way into third normal form that also preserves the dependencies. 3NF may be better than BCNF in some cases. And here are few examples. Fourth normal form. The fourth normal form eliminates interdependent many-to-one relationships between columns. To be in fourth normal form, a relation must be in Boyce-Codd normal form. A given relation may not contain more than one multi-valued attribute. And here are the examples. To convert some schema into fourth normal form, move the two multi-valued relations to separate tables. Identify a primary key for each one of the new entities. Fifth normal form. Fifth normal form is satisfied when all tables are broken into many tables as possible in order to avoid redundancy. Once it is in fifth normal form, it cannot be broken into smaller relations without changing the facts or the meaning. Domain key normal form. The relation is in DKNF when there can be no insertion or deletion anomalies in the database. Thank you.